Hey there, grade 5, bringing you the math lesson for today. So today we're going to be dealing with area and perimeter. So we already talked a bit about area and perimeter the other day, and you're going to be working in your math workbooks a little bit more today. But yeah, I was just going to bring you a quick lesson, and I think, you know what, it worked out great that we did a little bit of work with the arrays because we just had to do that much to prep for this lesson here today. So that's great. So we're going to look at multiplication to find a number of dots in an array. So I'm going to make a little array here like we had a few, I guess the beginning of last week or something like that. So this is a 4 by 3 array. And yeah, so it's 4 across, right? There's 4 dots along the top and there's three like vertically. So we would sometimes people would call this like 4 by 3 or 3 by 4 regardless. And so yeah, there's the question here is just how do you figure out how many dots are in here? Well, one way you can do it is just go 1 2 3 4 5 6 7 8 9 10 11 12. You can figure out that this equals 12 dots. The other way is just to take the top amount. So you just take 4 and then you multiply it by the number of, I guess, columns or rows, I guess. So you take the amount of columns and you multiply by the number of rows, or the other way around, really. And what you're looking at here is basically you're just saying, okay, well, there are 4 or 3 groups of 4 or 4 groups of 3, and yeah, you can see it here. So right, there's 4 groups of 3 here that I've basically shown. And so if you can see that, you just count the top and you say, okay, 4, and then you times it by 3, you'll get what? So we know 4 times 3 is equal to 12, the same thing. So what we're just trying to show here is that you can get the same number just by multiplying the length by the width, or yeah, I guess as we were talking about earlier, in a sense you could say the y by the x in an array, or the columns by the rows, and that'll give you the total number of dots. And you could do this for bigger ones, so if you had a larger one, it would be the same thing. And it's always just, it's kind of, you can think of it as just making groups of dots and then multiplying it. So this actually comes in useful all the time. I use this method without even remembering where I learned it, just all the time, to count things quicker. So you don't have to go 1 2 3 4 5. You can just count the top, count the side, and then multiply, and then you get it without having to count each dot. So in this case here, it might be easy. It might be fairly easy to count, but in larger cases, you're going to want to be able to multiply, and it helps you get the answer quite quickly. So that's awesome, right? So that's the basic idea there. So we're gonna look at how let me just show something a little bit, same kind of concept, but we're just going to sorry, I want bigger squares than that because I don't want to work with that. Let's look at a square that is similar. So if I take a square and I make it 4 squares long by 3 squares wide, how many squares total are in here? Well, we know that it's 4 squares wide and it's also 3 squares long, and we can actually do the exact same thing. Like, we can count it first, so let's just let's do that first. We'll use white. So let's say 1 2 3 4 5 6 7 8 9 10 11 12. Well, so it's 12. Now if we have, right, we have kind of like 4 squares long and 3 squares wide. Let's put a W, right? And we can also just multiply this, right? 4, I guess you could say 4 squares times 3 squares equals 12 squares. Now remember that we talked about square units. So yeah, this is going to get into square units. So what we notice that there's a similarity here, right? That with an array you can do this, and you can also do it when we're just dealing with standard little squares here. So we can also take a look at this over here. So let's move on to another option here. And how about I just draw something without the grid here? So it's going to be not as great, but let's take this like this. And if I say this one is 50 squares long, so obviously these would be little squares, and there's 30 squares long here, how would I find the final answer for how many squares make up the total? Well, I could imagine just that there's tons of tiny squares, or you could draw them all. You could chop this up into 50 equal parts, and this side into 30 equal parts, and then fill it all in. But that would take you a long time. Rather, you could just be like, oh, well, I know now from over here that if I multiply the length by the width, I can find the number of squares. And so yeah, that's true. So if you go 50 squares times 30 squares, you're going to get how many? Well, 5 times 3 is 15, and then you have the 2 zeros afterwards. So it's 1,500 or 1,500 squares. That's our unit, I guess, that we're working with right now. So yeah, 1,500 squares. So that's a quick and easy way to do it. So this is because the area is measured in squares, and we can think about this even when we're dealing with regular units. So we know that there is such thing as a square unit. So we can actually find the area of any rectangle that is, and we can think of it as made in squares. So let me just draw a little shape here. So this is another one, but this time instead I'm going to call this one, say this is 10 centimeters. And over here I'm going to say that this is 5 centimeters long. Well, the same thing applies. How would I find the area? Well, just like this, we could ask here, how many square centimeters, and remember what a square centimeter is. 1 square centimeter, 1 centimeter squared, and that's the way you write it with the 2 there, is equal to a little block like this with 1 centimeter along the top and 1 centimeter here and 1 over here and 1 centimeter here. So it's a little box made out of centimeters. So how many centimeters squared could I fit along the top here? Well, if each of these only takes up 1 centimeter along the top piece, you'll fit 10 whole centimeters squared along the top. And so you could just think of this as 10 whole centimeters. So you would just have these little squares almost. 1, 2, yeah, these might not end up being perfect. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you could have like 10 square centimeters along the top, and then you'd have 5 squared centimeters along the side. And then you can think about how many would fill in the rest. So 5, right? There's 5 centimeters length. So that's just counting the little line at the top. And this is also counting the little line at the thing. So these ones are just regular centimeters. They're measuring the length, not the area. So remember, length is measured just in regular old centimeters, and area, which is what fills in the shape, is measured in centimeters squared, or squared units. So it could be meters squared or kilometers squared or whatnot, but the regular unit measures length, the squared unit measures area. So if we were going to do this, just like what we did before, we can just go, okay, well, 10 centimeters times 5 centimeters equals 50 centimeters, and it's centimeters squared, right? Because we're finding the area, and it's like kind of like centimeter and centimeter get added together, give you the area there. And that gives you centimeters squared, so 50 centimeters. So it's pretty easy, right? So what we said, and I kind of mentioned this last time, so this is a bit of a review, seeing how I had a bit of a spoiler last time. Area of a rectangle, is equal to length. So I'll just do L times W. So length times width. And yeah, so we can always find that. So if I had a few other ones, let's just look here. Let's say I have a, we'll just take a little one here. I'll call this 8 and 4, so centimeters and centimeters. So how would we figure this one out? Well, we don't remember. We could think of it in the sense of having squared centimeters along here and there, or we could just know our formula. So if we want to figure this out, the area would be equal to length times width. So the length is 8, the width is 4. We times those together, and that would be equal to 32, right? And this would be 32 centimeters squared, because it's area, and these would actually be in centimeters and centimeters, right? So that's just one example. I could do, 3. Let's do 3 and 5. And what would we do? We just say area. We'll just say A is equal to length times width. And we would say that this is 5 centimeters times 3 centimeters. And that's going to be equal to a grand total of 15 centimeters squared. So I hope you get the idea. It's rather straightforward. You just measure the width and the length, and you times them together, and that's how you get rectangle area. So this doesn't work exactly for non-rectangles. We might get to that other, how to measure area of other shapes in this unit, but yeah, for now, this is what we're learning, just rectangles. And for rectangles, to find the area is simple length times width. And remember, you can think of this how we thought of it here, with making the squares along the top and squares along the side to fill it. These are square. We're kind of chopping it up into squares to calculate it. That's kind of how we view area. So guys, I hope you enjoyed the lesson, and we all had fun. Okay guys, cheers.